This is Outreach Coordinator Scott Asakawa with Nova Education. I'm here with my colleague Ralph Bouquet. He's the Outreach Coordinator for Nova Labs. And we welcome you to a Nova Education Back to School webinar. We're going to be talking a little bit today about the resources that Nova Education offers across a variety of different STEM subject areas. And we're just going to give you a little introduction as to what we offer, what's new, what's upcoming, as far as resources, multimedia-based resources that you can certainly use across a variety of levels to kick off the school year. With that, I'll have Ralph introduce our guest.
Hi, good afternoon, everyone, and thank you again for joining us for this webinar. I hope that everybody's had a great and very relaxing and restful summer break and vacation, and I hope you guys are all looking forward to the new school year. So basically, I just want to give a quick rundown of what this webinar is going to look like. I'm going to start off first with sort of outlining some of the newest Nova Education resources, as well as some resources from Nova Labs and resources that are now available on PBS Learning Media within the Nova Labs collection. And then we're going to have a presentation from our guest. Our guest today is Erin Dukeshire. She is a 6th grade science teacher at a school in Roxbury, Orchid Gardens, K-8 pilot school in
Roxbury, Massachusetts.
And we're really, really excited to have her here. She's going to be presenting a really great presentation on sort of the science and the Common Core and how to sort of meet the needs of students by also taking into consideration Common Core standards with regards to literacy and math as well. And so we're really excited to have her on board. So Erin, if you could just quickly introduce yourself.
Hi everybody, it's great to be with you today and starting the school year just like you. So best of luck with that.
Nice.
Great.
Yeah, so what we're going to do, so we're going to have a Q&A session after Erin's presentation. If you look to the left, you should see a toolbar that has an app for the Q&A. So feel free to sort of enter your questions there. And then towards the end of the presentation, we'll actually go over them and we'll answer them. And Erin and I will sort of do our best to answer your questions. And then after that, we'll close out with some announcements for some general new Nova resources that are coming up this fall. So let's sort of get into some of the resources. And basically, we're going to go through this presentation we prepared, just highlighting some of the great resources that we have available to you guys.
Okay, so we hope that what you see is the PowerPoint presentation that we have, and we'll just go right into it. Again, we want to welcome you, and if you have questions, please do feel free to enter those into the Q&A app, and we will come back to them at the end and do our best to attend as much as we possibly can. On agenda for today, we are going to be talking again about a lot of the multimedia digital resources that we have. And we're going to be discussing specifically how our resources can serve as supplementary content to the Common Core and NGSS standard curriculums. And this includes the presentation that Erin has been kind enough to prepare for us. After we go through that stuff, we're going to talk a little at the Q&A. You can pick our brains and Erin's brain a little bit, and as Ralph said, a little bit more announcements. And this is just a summary of the Q&A piece. The first thing that I want to talk about today is a brand new collection that Nova Education has released on PBS Learning Media. It's called The Design Process from Idea to Solution. This particular collection is the first collection that Nova Education has produced that we produced from start to finish all on our own. Usually Nova Education draws content, video content, from the documentary series on PBS. But in this case, we produced, edited, and delivered the content from start to finish. And this collection is designed to align well with the next generation science standards around design learning and design thinking. Using the resources that you can find on PBS-LM, which include four separate videos and 4 lesson plans, one corresponding to each video, we can really take learners through the process of building on raw ideas, raw potential, and building that into sustainable solutions that have genuine potential to really be the change in the future that we're looking to see. And it is designed essentially to be done with classrooms in context. You can take it from anywhere from sort of a 1 hour lesson spread out over in one class period, if you wanted to do any of these things individually, or it could take as much as 4 days. So it's a very, very flexible curriculum, and it's something that we think serves very well to supplement curricula around engineering specifically for middle to high school students, particularly for high school students. We did that collection as a part of the Making More Stuff outreach campaign. Nova Education has done a variety of different outreach campaigns around several of our different mini-series, and Making More Stuff is one of our more recent. It is specifically focused on topics in engineering and material science. So we released Making Stuff, the television piece, in October of 2013, and we've just now concluded with the design process collection our outreach around the series. So if you're looking to incorporate engineering into your classroom, we certainly encourage you to check out PBS Learning Media and check out what's there as far as stuff provided by Nova Education. In addition to that, we have a variety of resources built around some other areas of science. One of our favorite collections is the Earth System Science Collection. This is a great one if you're doing content around climate, around weather, around earth sciences. The Earth System Science Collection draws material directly from one of my favorite Nova episodes, series Earth from Space. It's a 2-hour special, and using NASA satellites and combining that with some really incredible animation, the folks that produced this series for us, which premiered in 2012, really outdid themselves, and it's gorgeous, gorgeous content. And we supplement that with a variety of teaching tips, discussion questions that are designed to use the compelling nature of Nova's television and really illuminate for students Earth system science on a global scale. So we really, really encourage that one. The next one that we want to talk about is a biology-centered piece, and Ralph's going to take over for us.
Yes. So Nova Labs is our citizen science platform. So if you go to pbs.org/nova/labs, you'll see a collection of labs there. And basically, each lab is built around an actual data set. And the idea behind Nova Labs is giving students sort of experience with the actual research and scientific tools that scientists actually use in the field. And so our RNA lab was a collaboration with a group at Carnegie Mellon University called the Turner Project, and they're developing basically crowdsourcing genetics and actually having people work together to build RNA biomolecules. And in this lab, you actually play the role of a molecular engineer who has to solve RNA folding puzzles in a game. So it's a puzzle game, actually. And it's a really great way to reinforce, if you're teaching protein synthesis, the RNA world hypothesis, or wanted to sort of discuss how viruses work, the RNA lab covers all those topics. And it's broken up into 4 different sections of the game, but it's a really great way to teach sort of these higher order level biology topics such as protein synthesis and particularly RNA. And it also features a lot of videos as well that also emphasize different aspects of genetics as well. In addition, so the Nova Elements app which is now available for the iPad and the Windows Surface, is also a really great resource for any chemistry teachers out there. The Nova Elements app basically provides an interactive periodic table, and students can tap on any element and learn more about where it's found. And actually, there's actually a part of the game that allows you to actually build an element from scratch, and students actually manipulate the subatomic particles and create different elements. It also features videos from the Nova Elements series hosted by David Pogue, and some really, really great videos as well to also reinforce the idea of the periodic table and how sort of all the elements work together to create so many different aspects of life.
So one last one, we wanted to touch a little bit on physics, and immediately what came to mind for me was Fabric of the Cosmos. This was a series that really gave a really interesting introduction to concepts in advanced physics that kind of push at the boundaries of current human knowledge with regard to the origin of the universe, and they do so by really taking some of the concepts, some of those concepts in physics, and really explaining them in quite an elegant way that we really enjoy. And there was quite a bit of outreach that we did in 2012 around Fabric of the Cosmos, using the content from the show to produce a variety of different resources that we really think can do well to introduce students to the field of physics and its potential application as far as answering some of the world's most pressing questions. I would certainly recommend that if you're interested in checking out anything as far as physics is concerned, please do check out pbslearningmedia.org as well as Nova Education's website. PBS.org just underwent a redesign, so you definitely, if you haven't been in a while, you should certainly check it out.
And finally, for teachers who are interested in Nova Labs, on PBS Learning Media, there's actually a Nova Labs collection now that features lesson plans, video resources, and discussion questions related to all the labs. So every video that you'll find in the labs, you can also find here. And they're all supplemented with discussion questions and sort of short answer questions that you can use in your classroom. In addition to lesson plans, provide a variety of different activities and creative ideas for how to implement the labs into your classroom. So definitely take a look there.
Okay, so that's about it for our part of the presentation. We hope that we've directed you to some interesting resources, and that if you have any questions, please do feel free to get in touch with us. We'll give you our contact info at the end of the presentation. But now we'd love to introduce our guest. As we said, her name is Erin Dukeshire. She is a 6th grade science teacher at Orchard Gardens K-8 pilot school, which is in Roxbury, Massachusetts. And she's also, we thought this was really cool, a recipient of the Presidential Award for Excellence in Mathematics and Science Teaching. So we are really, really excited to have Erin on to discuss what she does as far as practice in the classroom and educating in the classroom, and we're really looking forward to hearing how what her perspective is on integrating resources like ours into classroom teaching. Erin, with that, take it away.
Thanks. So, oops, sorry, one second. Hi everyone. So this is a photo of the students that we actually are sending off to high school this fall from our 8th grade last year, and they were a bit younger here, but we spent some time with them out on the islands in the Boston Harbor, and then got to spend today with my science team thinking about the growth that they made during their 3 years in the middle school at our school. So just wanted to share a bit about those guys, because that's really why we're all here, is for the students that we have started to or are about to start teaching. So if we could go to the next slide, I will share with you a little bit about my sort of philosophy with teaching science just in general. There we go. Okay, excellent, thanks. So that's me in the corner crossed out because it's really important to me as I develop my practice as a teacher that I'm learning more and more about how to make sure that students are becoming independent learners of science. I mean independent of me, not of each other. So I really like to use collaboration among students, text, and then data and observation to help students develop understandings themselves, acquire knowledge themselves, acquire skills themselves with me as a coach, and step out of the picture as much as possible. So on the next slide, you can see that sort of my big idea that I hope comes across today is that in implementing Common Core state standards for reading in science and technical subjects, I've helped my students become more independent learners of content standards in science. I think it makes sense to begin by just making sure we're all grounded in sort of the landscape of science standards because it has been changing. So on the next slide, you can see that there's really two groups of standards that are impacting our work in many states right now. So the Common Core state standards and the next generation science standards are really driving the science instruction in states where one or both sets of those standards have been adopted. I want to talk first about the next generation science standards. On the next slide, great, thanks. You can see, so the next generation science standards, each standard has three parts to it. Each standard has a scientific practice, each standard contains a cross-cutting concept, and each standard contains a disciplinary core idea. The way that I map this new set of thinking with NGSS, the practices, cross-cutting concepts, and disciplinary core ideas, the way I map those onto the way I thought about teaching science before is that practices are sort of like the science skills, cross-cutting concepts are sort of like the understandings that my kids need to develop, and disciplinary core ideas are sort of the knowledge that they need to acquire. I can show you an example of a next generation science standard. Construct a scientific explanation based on evidence for the role of photosynthesis in the cycling of matter and flow and energy into and out of organisms. And we can see here the blue is the scientific practice. Students are expected to be constructing explanations based on evidence. The green is the cross-cutting concept. Throughout the next generation science standards, students are returning to the idea of matter and energy cycling, flowing. And then the disciplinary core idea is about the fact that photosynthesis is responsible for that cycling of matter, flow of energy into and out of organisms. I'd also like to talk, though, a little bit about the Common Core state standards. So in the Common Core state standards, which are different from the next generation science standards, the Common Core state standards have standards for reading, writing, and math. And then within the reading standards, there are a set of standards for a science class. These are not the same standards that my sixth grade, my colleague down the hall is teaching in sixth grade ELA. They're very tightly connected, but they're a different set of standards that show how students should be using text in science class. There are also standards for writing in science and technical subjects. Those just aren't the focus today. And I can show you an example of a Common Core state standard for reading in science and technical subjects. This is one we'll look at an example of shortly. Integrate quantitative or technical information expressed in words in a text with a version of that information expressed visually. For example, in a flowchart, diagram, model, graph, or table. So if we look at the intersection of those two sets of standards, which are the standards we're operating with in Massachusetts, and in your states you may be operating with one set or both sets, or in some places just continuing with your state's previous standards. But we see that really what's influencing the standards in my science, or what's influencing the instruction in my science class, are both literacy standards that come from Common Core but are specific for a science class, and then also the practices, cross-cutting concepts, and disciplinary core ideas from the next generation science standards. What I'm going to show you an example of in a moment is a lesson that I use that I've developed over the last few years and really continued to tweak that is not an example that is aligned yet, I say, to the next generation science standards. The lesson is designed to teach the old Massachusetts standard about photosynthesis for middle school, which you can see here. And that's because we haven't fully adopted the standards yet. That will be happening in Massachusetts next year. But I have listed underneath the Massachusetts standards, the standards in the next generation standards that are related to photosynthesis. Excuse me. What I do want to focus on with this example is how I found a way to use the Common Core state standard for reading and science and technical subject to support my students' learning of the content standard about photosynthesis, and to do that in a way where they're really independent of me, where I don't need to tell them the information. Instead, they're using a text to learn that information for themselves, and they're using collaboration amongst each other to learn. I also, in this lesson, incorporated models because I wanted to experiment a bit with the next generation science standard practice, excuse me, of developing and using models. So I want to show you 3 different resources that were important for this lesson. Students learned about photosynthesis. They learned the standard, the Massachusetts standard, using a text that came from Kids Discover, and you can see the website listed there. And they also used 2 different models. One is a model using Legos, and one is a model using cards. Now, I actually developed this whole Lego model lesson, and then found out that MIT had also done the same thing. So there's a link there to what they to their resources for a similar lesson. And then the card version of the model that you'll see in a moment is where it was really developed after I saw a session at the NSTA conference in the spring by BSCS. So in this lesson, students are using a text and integrating the text with 2 different models in order to learn the content standard. And they're using that text replaces what I used to do, which was to stand at the front of the room and say, build a carbon dioxide molecule, here's what it looks like, make 6 of them. They don't need me to do that. So here's what the lesson looks like a little bit. On the next slide, you can see the text that the students use. We begin the lesson by, I preview for them the text features. So we look together at the diagram. We look at the flow chart, and also I model for them how to use the flow chart because it's new for a lot of my students. And we also look at the paragraphs at the top of the page. I read the entire text aloud before we start to preview difficult vocabulary and so that they can hear how I use the text. Then I ask students to get into groups, and as you can see, I give them a set of orange cards. The orange cards represent the different reactants and products involved in photosynthesis, and in my classroom we call them inputs and outputs instead of reactants and products, to use familiar terminology from math as they're getting used to this idea having to do with chemical reactions done in the plant during photosynthesis. So students use the text to figure out which of those cards belong in inputs and which belong in outputs. I've pulled out on this slide an example of a couple of sentences in the text, and then also when my students were working in a group, this is what one of the girls was saying. And also all of these girls there was a group of girls, including the student Rosangela, who were all pretty low-level English language learners. But here's what they were able to figure out. Rosangela says, it says in the text, plants use energy from the sunlight to produce the food they need to survive. So sunlights go inside for them to produce the food they need to survive, to eat the food. And then her group realized they needed to take the sunlight card and put it under inputs because in the text they found where it told them to do that. So students go through that process using the text to place the cards in the correct column, and then I check their work. And then I introduce to them a second version of the models. And I give them cards, a set of pink cards, that have a molecular representation, or representation of the molecules of the different materials involved in photosynthesis. And students go back to the text. And so for this, I direct them to the flow chart. I say use the flow chart to find which of these different pictures of molecules go with which of your inputs and outputs. So that's where students look at the flow chart, they find the water molecules, they have to match up the different molecules and use the labels on the picture, and they realize, let's take this pink card and match it of a water molecule and put it with water. Once they complete that for the inputs and the outputs, they get checked. And you'll notice I actually, in the text that I use, I block the picture of glucose molecule because I want them to figure that out during the lesson, figure out how to make that molecule. So then students get checked, and the next thing that I have them do is build a Lego molecule. So I give them a key, and they use the text, and they use the card model they've developed, and then they have to figure out, how do I use Legos to build a model of a carbon dioxide molecule? Once they do that, which requires actually very little support from me, they're pretty successful with this part, I check their work. And then depending on the student, I either tell them, okay, now make a certain number of carbon dioxide molecules, or I write the equation on the board and they have to figure out for themselves what to do. Then we can see where they take their molecules and they put them all in a leaf that I give them. And now comes the part that's really difficult, but really at the right level for my students, I find. I tell them to use the flow chart to find out what has to happen to those molecules in the leaf in order for the plant to do photosynthesis. So what are the steps the plant does? Students really struggle, but I direct them back to the text and say, look at the text. What does it say happens to the water? What do you see happening to the water? They read it aloud with their groups, they look at the pictures, and they figure out what they need to do with the Legos to replicate the reactions involved in photosynthesis. And at the end, they end up creating a glucose molecule and seeing that the oxygen molecules made out of the Legos are coming out of the leaf. They're released from the leaf. So after students do this, we do a couple different things. One is I have students write a description of photosynthesis. And again, they've only used text and the models to do this, and that's really what Common Core is suggesting they should be doing to learn. I haven't told them any information so far. So students work in groups to write a description of the process of photosynthesis. And then the other thing that we did is we used their learning to come up with questions that were testable for our spring science fair. And the questions needed to be about photosynthesis. So I asked the students to brainstorm ways that they could manipulate plants to begin the questioning process. Now you can see that the student on the left here, student number 1, he gets it. Like in his ideas of how to manipulate a plant and like things he might do to the plant that might cause an interesting response, he lists blow the plant. He told me he actually meant blow on the plant, block it from the sun, and change the amount of water. He's named all of the inputs that he learned about in the photosynthesis lesson. He gets that you can manipulate those. But student number 2 doesn't really get it yet. Student number 2 is listing no ways to manipulate the plant that have anything to do with photosynthesis. So this is where I would want to bring in one of the resources from NOVA, which we can see. It's called Illuminating Photosynthesis. I really feel like student 2 either needed me to pre-teach before the model, or needs me to loop back with her and teach her this information in a slightly different way. What I like about Illuminating Photosynthesis as a way to help that student is that it really helps to integrate text and a visual representation in a similar way that the model did. So there's a step-by-step molecular model that's the same process the students were doing with the Legos, and the same process represented in the flow chart on the handout. But here they can see it happening in sort of a video. They can click through it for students who need more of that step-by-step, and they can read the captions. So they're still integrating text with a molecular model. The other thing is just the animation that we can see on the bottom of this screen. It really allows students to integrate the particle model, which here are just represented by different colored dots representing carbon dioxide, water, and oxygen. And that's really integrated with sort of the macroscopic model of this picture of a plant and a watering can and the window and the girl. So it's still that Common Core skill of integrating text with models and visual representations, but in a different way for a student who didn't quite get it the first time. And I just want to sort of close by giving you a chance to take a look at what my students, this is an example of student work that came from a student who had gone through this modeling lesson and on the test was just asked to describe photosynthesis. And the student gives a really complete description of the process, and it was based entirely on using text, integrating the text with a model collaboratively with a group, and I didn't have to provide any direct instruction at all. So I'm really proud of what the student was able to produce. So that's one example of a way that I've integrated Common Core state standards, and also how one of the NOVA resources really plays into to support struggling students either before or at the end of my lesson.
Well, that's great. Thank you, Erin, so much for that presentation, because I think it was really, it did a great job of illuminating not just the incorporation of media, but also kind of a way to do it that is still very, very connected to standards and the evolving sort of landscape of the standards. That being the case, I sort of had a question. Given the introduction of NGSS and Common Core, what has been the most challenging thing for you as far as developing innovative curriculum?
Sure. So I have to admit that I love the challenge of developing innovative curricula, but as a leader of a science team, it has been challenging to get everybody on the team to buy into the need to start shifting to NGSS early. I do have colleagues that when students struggle want to jump to, okay, I'm just going to define this word for them and have them memorize it. And you know, NGSS tells us that that's not the right way to do it. Kids need to be creating explanations based on evidence, and they need to be modeling. But I think as a teacher leader, getting buy-in from others is sometimes challenging. And then also sometimes, to be honest, finding a text can be difficult. Like I stumbled across a text that was perfect for the photosynthesis lesson. But sometimes it is difficult to find a text that is at your kid's level or at grade level and integrates really well with what you're looking to teach.
Great, great. Ralph, did you happen to have any questions?
Yeah, so I guess my question, so you obviously did work of sort of finding out which Common Core standards would make sense with the content that you were teaching. Is there a place where you could find those connections really easily with each standard?
So in the NGSS documents, then there are connections to the different, like that document does contain connections to the Common Core state standards. I know in Massachusetts' version of NGSS, our draft of the new standards, it's incorporated like right under the physical science standards. Here's what this connects to. So a lot of that information is already out there. And there's like an easy one is just if the NGSS standard includes begins with the practice of modeling, well then your Common Core standard of integrating models with text is sort of a no-brainer. Similarly, constructing an argument, if that's the practice in an NGSS standard, then the Common Core standard of using a claim and evidence and reasoning to back up that claim, that makes a lot of sense.
Do you find that those that the standards commonly exist in overlapping space?
I do, and there's some that I still need to, I started with the easy ones. I once heard the advice that when you're implementing these new Common Core standards or NGSS, pick a few starting points and get good at those, and then keep transitioning. And so I started with the low-hanging fruit. I said I'm going to start figuring out how to teach these Common Core state standards for science that are the easy ones that really connect, and then now I'm ready to kind of look at the ones that are trickier and I'm not quite sure how to integrate them and then figure that out.
How long, I mean, your lesson just looks fantastic and it looks so detailed and considered. How long did it take you to develop it?
So I've taught a version of this lesson over the 3 years, and the first time I taught it, like I said, it was just me saying, like, I wanted kids to really play with breaking apart molecules and remaking molecules. in the context of photosynthesis. And so I said, build carbon dioxide, it looks like this. Build water, it looks like this. And then the trick for them was figuring out how to like break apart and remake those new molecules. And then last year I incorporated text, and then this year I learned more about the models and incorporated that. So in terms of like time to put the lesson together, I'm actually not quite sure. It was a really quick transition. Like once I saw this great example of using cards in the model at the NSTA conference, that was super fast to develop that revision because I'd seen a really strong example.
Great. Well, now is the time that I would like to invite anyone that's watching at home or at work to ask any questions that you might have of Aaron. In the meantime, I'm going to let Ralph talk a little bit about some of the upcoming exciting things that are happening in the world of NOVA.
Nice, thanks, Scott. So I just wanted to give a few announcements regarding some new resources that we have coming out. Let me just pull this up here. There we go. So first, we have a few NOVA episodes that are coming out in September. So first one is vaccines. And actually, if you go to Vaccines Calling the Shots or go to the main NOVA website, you'll actually see a trailer for it. But it's basically sort of an overview of sort of this controversy over vaccines and the danger that not vaccinating your children actually causes in a lot of these communities. And so really, really great profile of that issue. And then later on that month, we also have the Rise of the Hackers special, which will be actually great because it's coinciding with the launch of our new cybersecurity lab. So next month in September, we'll be launching the cybersecurity lab. It's basically a game that teaches cyber safety skills and strategies. It's broken up into 3 sections, one that focuses on understanding social engineering, another one that teaches basic coding skills, and then the 3rd section, which discusses and basically helps people develop better passwords. And so we're really, really excited about this lab. It's also going to come with some really great videos that talk about introduce basic computer science principles, and it's a great resource for anybody who is working in tech within schools. Obviously, there's a growing interest in coding and computer science in K-12 schools, so this is a really great way that if you have students who, like most students are these days, who are really plugged in into the internet, this is a really great way to teach these important strategies for staying safe online and making sure that your information and your privacy is protected at all times. In addition, we'll also be releasing some new educator resources for the RNA lab, including a lesson plan for the RNA lab, as well as video resources and discussion questions. So that will be coming out soon. And if you stay posted if you stay in touch with us on our Facebook and our Twitter pages, you'll see announcements for those resources as soon as they are available. In addition, always stay tuned into the NOVA Education blog. We have some really great features planned for the next few months, working with some different organizations, and as well, we'll also be talking about social media in our next post, which we're really excited about. In addition, PBS Learning Media, as always, contains some really great collections, and we'll be sure to keep you posted as those come out. And as always, please keep in touch with us and stay updated with all the new things that are happening in NOVA. If you follow us on Facebook and on Twitter, so for NOVA Education, it's simply NOVA Education, one word, and on Twitter, we're the NOVA Labs. So definitely stay tuned for updates.
And with that, we're having a look at our Q&A app, and it looks like, Aaron, you answered every question. Fantastic.
Great.
Please, folks, for those of you watching live, we appreciate you watching live. We understand that we are here on the East Coast, and unfortunately, our colleagues on the West Coast are still in the middle of the school day. So obviously, we hope that those folks and anybody that can watches after the fact. So please encourage your colleagues, if you get a chance, to have a look here. And please do be in touch with us, as Ralph said. We're always here to try to help you to continue the great work of teaching STEM subjects in schools. With that, we'd like to thank Erin for being our guest. So thank you very much, Erin.
Thank you. Thank you guys so much for having me. It was fun to hear about your resources and to get to share.
Absolutely. And Erin, we wish you luck in the new school year. We wish everyone luck in the new school year, and we'll see you again soon. Thanks a lot.
Thank you.